Hi, my name is Jingqian. This is my Applied Deep Learning project. In this project, I used convolutional neural network to do cancer detection from pathology images. Nowadays, deep learning technology has been widely used in the medical industry. One of the most exciting usage is cancer detection from the pathology scans. The benefit of using CNN is it has a high accuracy. It is time saving once you have a well trained model. It is very helpful for the physicians. In this project, I used slides from the Chameleon 16 challenge and take the Google group paper as reference. First, let's take a look at our slides. We could see that these two are the two slides I randomly selected. So they are very unsimilar, and we could see the tissue region is only a small part of the image. So we need to do some image pre-processing before running the models. Here, we extract patches from slides and take patches as our training or testing data. We label the patches as a tumor if its center region has tumors. A little different from the paper as we used the 128 squared pixels in level 3 instead of level 0 because we have a small data set. And we remove the background and we cut the edges to increase the probabilities to get the tissue regions. In this project, I tried several different models. To start with, I used a pre-trained Inception V3 with ImageNet. We could see that although our dataset is quite small, it has a high training and validation accuracy, and it is the quickest of all the models. Then I also tried initialized with a random input, and it has a lower training and validation accuracy, but still reasonable. Then I add fine-tuning to the Inception 3, and it has a lower training accuracy and the speed is slower. I also tried a self-defined CNN, so it is not Inception V3 and it's super slow, and it ate all my collab memories, so it's a bad idea. And I also tried the multi-scale models with Inception 3. We could see that it has the second highest performance of all the models, and its speed is a little lower than the first one. So here I want to explain a little about the multi-scale models. It's like a real human doctors. They decide whether there is a tumor through looking at multi-scale images of the same center region of interest. Like this one, the left is level 3 and the right is level 4. So the level 3 downsampled by twice gets the level 4 is the center yellow region, and we decide whether it has a tumor inside by looking at the center 128 squared red regions to decide whether it's a tumor region or not. So here, let's look at the performance of our model. First, let's look at the heat map of the testing slides. This one is the heat map overlaid with the sample image of slides 101. We could see that the dark purple region are the tissues without tumors, and the red regions are our model predicted it has a high probability to have cancer. Then let's look at this one as 110, this one is 23. Here we could also use the heat map of predicted cancers to decide which model is better for the job. And the left corner is the ground truth, red place as the tumor region. and the middle one is the single-scale model prediction, and the upper one is the multi-scale model. We could see that the single-scale has a better prediction job than the multi-scale one, but it still has some center false positive regions. Other than that, we could use some metrics to decide whether the model is good or not. People usually use ROC curve to evaluate whether the model does a good job in binary classification task. It describes how good the model is at predicting the positive class. You could see that when the actual count is positive. So the ROC curve is a useful tool for such reasons. We could see that we could compare the two models by directly looking at their curves. If it deviates from the diagonal, it has a better performance. So obviously, we could see that the left one is better because it's higher, much higher than the and much far away from the diagonal. And we could also get the area under the curve. It's called AUC score as a summary of the model scale. The higher, the better. So we could see 0.87 vs 0.74, so the left one is better. We could also use the precision and the recall curve when there is an unbalanced data, especially when there are many examples of class 0 but has only a few examples of class 1. Like here, we have much more place of non-tumor regions than the tumor regions. So let's look at this one. Similar to the ROC curve, if it deviates from the diagonal better, it has a higher score. So we could see the left one is better than the right one. And we could use the F1 score from the precision recall curve to see whether this model is better or not. We could see that from the F1 score, the single scale model is much better than the F1 score. And if you remember the last picture, we compared with these two values. This one we compared with these two values. We could see that F1 score has a better differentiation ability. So to summarize, in our models, the pre-trained inception V3 with single high-resolution scale has the best performance of all the models. Although we have a small training dataset, we still get a reasonable prediction accuracy. The main reason prevents us to get a high prediction accuracy has such reasons. We may need more training data. We may need more optimal model and parameters. And we want to have advanced method to extract tissue regions in training. And although we have unbalanced data, we find that through F1 score or use the precision recall curve, we could evaluate the model very good. Then let's look at the notebook. Let's take a glance at. So this one is what I used to project all my pictures and the results. So this notebook consists of 4 parts. The first one is image processing. I import data and I take a glance of all the slides, and then I generate all the training patches and the corresponding labels. This part I generate both level 3 and level 4 for multi-scale task. And then in the second part, I did model selection. So first, I tried the transfer learning with Inception V3. We could see that it has a high accuracy, and I also tried the random initialization, the fine-tuning, the multi-scale model, and also myself defined the CN model, but it's not good and it's slow, so no. And the third part is the selected model performance. Here I choose the single model vs the multi-scale model. I showed their heat map. I showed their log curve and OCT scores, and I showed their recall precision curve and their F1 scores. And finally is my discussion. That's all. Thank you for listening to my report. Bye.